Hi, welcome to worksheet 24. This is section 5.1 from the textbook, Area Between Curves. In this section, we'll further study the integral in terms of area. The literal definition back when we first talked about integral, the literal definition of integral is the area under the curve, graph of a function, right? So we started from like rectangle, and we had a bunch of rectangles. We took the limit as n goes to infinity, and then we called that an integral. So we started as the area under the curve. Of one function, area under the curve, right? You can use that to find the area bounded by two different functions. So here I'm going to highlight here two different functions. So this one, we're going to kind of take that idea, and then like, what if we have two graphs, and then we're trying to find the area in between those two functions, right? So that's what we're going to do. We'll also find the integral where variable is y instead of x. So that's going to change things a little bit just because we're using different variable. Everything else is going to be the same, that we're just using the different variable. All right, let's look at the area bounded by two or more curves, right? So goal is to apply definite integral to find the area between two curves, right? Notice that it's not just area under one curve. So for example, if you look at the graph like below here, I have one function f of x here, and then I have another function g of x. And then we're trying to find the area between these two curves. So before it was like f of x and then area under the curve. So it was kind of like rectangle-ish, except the top part was different. Here, top part is a curve, bottom part is another curve. So this is more irregular shape. So area A is, we have two functions, f of x and g of x. And notice here that f of x is always on top of g of x. So f of x is bigger than or equal to g of x. So this is top function, this is bottom function. Basically, how to find this area, we'll go integral f of x minus g of x dx. So if I have just one function, is f of x dx, that's it. Here I have f of x and g of x, and its area between. So this is top function. So I'm going to make a label here. This is my top function. This is my bottom function. OK. Let's see how that came about. So we'll kind of, the way we came up with that formula is basically we kind of go through the same process. So here, if you look at one rectangle, find the area of one rectangle, and then we have a bunch of rectangles and let n goes to infinity, basically. So area of one rectangle, the ith subinterval. So if you just pick one particular subinterval, the rectangle's height is going to be, well, let's look at the first one. Height is of this rectangle is from here to here, right? So height of the blue line is f of x. Height of the red line is g of x. So this height is, so this is g of x, this is f of x. So the difference between these two curves, height gives you the height of this rectangle. So that's height of the ith rectangle is f of xi star. So sample point from ith rectangle, and then we're applying f of x. That means it's the height of this portion, right? And then I'm going to do subtract g of xi star. So that's height of g. So when you subtract that, that gives you the difference, which is this height. So that's the green rectangle. And then you just basically multiply that by the delta x, right? So that part is pretty much the same. So once we have that, and then basically we're just adding that up. So area of the sum of the areas. So that's one particular rectangle. We have n of those. So summation I goes to 1 to n. And basically it's f of xi star minus g of xi star delta x. And again, when you take the limit of that, that is just called the integral. So it's pretty much the same process of how we came up with the integral. So important to notice that the function, there's a top function and there's a bottom function. So I want to make sure, it's like, how do you know is g minus f or f minus g? Whatever is on top is here, and then whatever is at the bottom is there. So I'm going to again make a note here, top and bottom. Sometimes it's going to be hard to figure out which is the top, which is the bottom. So we'll kind of talk about how do you know which is f and which is g. OK, so we have let's look at example 1. Find the area bounded by curve this and that. So here they label it F, label it G. It doesn't mean F is on the top. I just mean like it literally has to be, when I graph it, it has to be on the top, right? So just because it's labeled F, it doesn't mean that's the top function, right? How do you know which function is in the top, which function is the bottom? So first, I have a square function. This is parabola, right? So my parabola is going to look like this. So generally speaking, if you have a parabola, x squared and blah, 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 something, and then if you look at x squared, the coefficient is 1, which is a positive number. So the graph is general graph of this is going to look like this. And then g of x is also parabola, and then it's negative x squared, so the graph is going to like this, right? So I guess my question is, how do I know? So I'm going to try to graph it. How do I know it's going to look like this? This is F, this is G. Or how do I know it's going to look like G and F, right? So it kind of depends. Like if it looks like this, then F is the top function. If it looks like this, then G of this, G is the top function, right? So let's look at G of x. Here I'm gonna, because I'm trying to graph G of x, maybe I can factor out x. So x times 4 minus x. That means x goes to 0 and x goes to the, so it goes to 0, 0, and then it goes to 4, 0, right? So if I were to graph it, here, it goes to 0, 0, and then it also goes to 4, 0. And we know that g of x has negative coefficient for x squared, so it goes like this. So my guess is it's going to look something like this, right? Okay, 0, 0, and 4, 0. So 4, 0, 0, 0. How about f of x? I'm going to try to complete the square, so it's x minus 2 squared. If I just do x minus 2 squared, I get x squared minus 4x plus 4, right? But it's, my function is x squared minus 4x plus 10, so I need plus 6, because then it'll be that. So that means your vertex is at 2 and then 6. So vertex is 1, 2, and then 6. And then again, we know that this has a leading coefficient 1, which is positive, so it's going to be like that. So it's going to be like this. It's going to be like this, right? Just to check. Let's just plug in some sample point. Let when x is equal to 2, f of 2 is equal to, plug in 2 into here, you'll get 6 as an answer. G of 2 is plug in 2 here, right? And you'll get 4 times 2 is 8 minus 4, so I get 4. So f is bigger than g. So then I know the f function is always bigger than g of x. So in this type of question, it's really important to know the graph so that I know which is top and which is the bottom, right? Sometimes the graph, they meet. Here, how do I know when they meet? Here, just by looking at the graph, they don't meet, but we can solve algebraically how they meet. So f of x is equal to g of x. Because later on, it becomes important way they meet, because sometimes when they meet, like f becomes, top function becomes the bottom function, and then bottom becomes the top. So here, f is always in the top, g is always in the bottom. There are some questions where at some portion, one function is on the top, and then it switches, right? So how do I know when they switch? When they meet, right? So when two functions intersect. So how do I find that where functions intersect? When you let them equal to each other. And solve for x. So x squared minus 4x plus 10 is equal to 4x minus x squared. I want to try to solve it. So that'll be 2x squared. I'm going to move this here, so it becomes 2x squared. I'm going to move here, so there's negative 8x plus 10 is equal to 0. X squared minus divide by 2 is like this, is equal to 0. I want to try to solve it by using quadratic equation. Quadratic formula, so x is equal to 4 plus minus 4 squared minus 4 times 1 times 5 over 2. When we calculate this this part, 4 squared is 16 minus 20, so that's negative. Square root of negative, that's not a real number, so it doesn't exist, right? no solution. That means they don't meet, as we can see here. So here I don't have to worry about the part that where they meet, and maybe f becomes bottom function, but it doesn't happen like that. So all right, fine. So how do I actually answer the question? Sorry. So I'm going to set up the integral like this. I go from 1 to 3. So they say between 1 and 3. And then basically go f minus g dx. So 1 to 3, x squared minus 4x plus 10 minus 4x minus negative x squared, so plus x squared dx. So that's my setup. And when you solve this part, the answer is going to be 5 1/3. So once I have that, then it'll just be normal, just finding an integral from 1 to 3. So once you calculate that, you're going to get that as an answer. So this area indicated by 1 is here, and then 3 is here. So I just found out this area right here. So it's bounded by this function on the top and then this function on the bottom. All right, let's look at the next example 2. Find the area bounded by curve this and that. So again, negative x squared, so you'll see something graph that looks something like this. This is cubic. General shape of cubic when the leading coefficient is positive is like this, right? So for polynomials, like square has 1 turn, cubic has like 2 turns, right? If it's positive, then it goes like this. If this was negative 2, then graph is going to look something like this, right? Opposite. So here it's nice that the graph is given. So this one is this, and then the first one is this, right? So let me label that. 2x cubed minus x squared minus 5x. And then this one is negative x squared plus 3x, right? So here is our, I have to be super careful. From negative 2 to 0, this function is on the top, the cubic function is on the top. However, from 0 to 2, the square function is on the top, right? So we need to kind of split our integral. It has to be top minus bottom. How do you know it's going to be 0, 0, 2, 2, right? Well, here they gave it to us, right? But how was I supposed to find that out? So again, if they didn't give you the graph, I have to kind of do it myself. But basically, I have to let these two functions equal to each other. So is equal to negative x squared plus 3x. This gives you the point. This is to find where they meet, right? So 2x cubed. Move this on the other side, so that becomes 0, and then negative 8x is equal to 0. So 2x x squared minus 4 is equal to 0. 2x x minus 2, x plus 2 is equal to 0. So x is equal to 0, negative 2, and 2. So 0, negative 2, and 2. So I know these three are the points where they meet. So from there, either I know the graph, and you can kind of check sample point, like when x is equal to negative 1, plug it into here, negative 1 here, see which is higher. You'll notice that x cubed will be higher. Plug in 1 to this and see which is higher number. Then you'll notice that this is higher number, so I know that this is the top. So the setup of the equation integral is going to be like this. Negative 2 to 0, so from negative 2 to 0. What function is higher? The cubic function is higher, so I'm going to put the cubic function first. 2x cubed minus x squared minus 5x minus the lower function is the square function, so negative x squared plus 3x dx. That's the first part, so this is part A, I'm going to call it. And then plus, I'm going to do from 0 to 2, and then the other way around, x squared plus 3x minus 2x cubed minus x squared minus 5x dx. So this is area B here. So this is very important. I split it into two parts and calculate the answer. So when you actually calculate the answer out, you get plus 8, and you get 16 as the final answer. Oh, interesting. So this area is same as that area. Turned out to be. All right. Okay, let's look at the next part here. Next one, find the area between two curves. Okay, using y as the variable. All right, we want to use them when the function is on the right side of the other function. So if you look at the graph here, the orientation of the graph is like this and this. So this is no longer a function of x, like the vertical line test doesn't work. But if you could think of y as a variable, then it could be a function, right? So when your function is oriented this way, right? So it's like, oh, my bar is going this way. It's like, what? It's a little weird. So your delta x is not this part, delta y, and I have to look at it in terms of delta y. So this is going to be like the base of the rectangle, and this is the height of the rectangle. And again, in terms of x-axis, here, maybe I can write it out here. The right side is higher number, higher x values, right? And then left side is lower x value, right? So here, right side is higher value. That's the top function. And the left side is lower value. So that's your bottom function. So I'm going to label that as this is the top, this is the bottom. So the structure is basically the same. We're going to do like top function minus the bottom function, except now it's not the top orientation is not changed. Top is basically the right function. So I'm going to write here is the right function, and then this is the left function, right? So right function works as a top because value here is larger value. So, and then left function works as the bottom because this part is the lower value. So instead of using x as a variable, now using y as variable, right? So you have to, your brain has to do some sort of switching a little bit. Okay, so basically we kind of go through the same process to get this, right? All right, let's see. So like these kind of questions, the math itself is not that difficult, but setting up it just feels weird because we never set it up in terms of y. We always set it up as x squared or whatever, but now things are going to be in terms of like a y squared or something. So I'm looking at the graph here. If you look at the graph, this is like not oriented like this. It is oriented sideways, right? So again, if you look at top to bottom, like I have one function here, I have this here. If you do top to bottom, that's fine, fine, fine. It's always the curve minus the line. Except when I look at here, this is again where things get a little weird. It's like, oh, it's this curve minus this, top and bottom, right? So it's just going to be weird if I do top and bottom. So maybe it's not the top and bottom. If I do right to left, right is always a straight line, and the left is always the curve, right? So if I look at here, right is the straight line, left is the curve. So how do I determine is it better to set up integral versus dx versus dy? So is it better to do top and bottom? Yes, maybe it's okay here, except now I have to do like this minus that, like I thought it was the same graph. So that's going to make things more complicated. But if I do right left, it's always the straight line and then the curve. So that makes it easier. So find the area bounded by the parabola this and the line that. And here I'm going to do dy because the right minus left will be easier in this case. Because if I did top minus bottom, it's like, what top is this, bottom is this, like how am I supposed to use the same function twice? That makes things more difficult. So that means that means it's going to be dy. That means your function has to be given in terms of y. So the first one is fine. The function, your function is given in terms of y. Here I have to rewrite it. So I'm going to just rewrite it. X is equal to y plus 1. So now your variable has to be in terms of y. So I have to do a little preliminary stuff. Like this is given in terms of like function of x. No, I don't want it that way. I want it function of y if I'm doing right to left, because that will make dy. So once I have that, so I have to decide, okay, the straight line is going to be the top function. So this is going to be the top, this is the bottom. Right. All right, so once I have that, then I'm going to set up my integral top function minus the bottom function. I'm going to dy. Now I have to look at like what's the integration limit. Here I'm looking at this way. So what's the highest y value? Should I put 5 or 4? Well, 5 is x value, 4 is the y value, and this is dy. So I have to tell them which y to go from, and then which y do you go up until. So y is 4 is the highest y value, so that's going to be my upper limit. So I'm going to make this to here, 4. How about the lowest value? Y value is right here. So that's -2 is the lowest y value. So that's my lower limit. So that part has to be also be careful. Like, how do I know which number to pick? There are 3 numbers, 3 sets of numbers, right? Well, this is y, so I'm looking at the y values. If I'm looking at the region, what's the highest y value? That's 4. What's the lowest y value? That's -2. So this will be my integral to set up. And once you calculate it out, you get 18 as an answer. All right, I'm going to have you look at example 4. I'm going to have you pause, finish number 4, and see what happens. Just a hint, I have this radical function. General shape of the radical is like this way, right? And then this is a straight line. So I have pause, work on number 4, and then we'll meet back at the next example. All right, if you're done with 4, just kind of check your answer. If I were to graph this, the first one is the square root of x. So when x is equal to 0, you get 1. So I get this here, and then it's radical. So let's say I plug in 9. The radical 9 is 3 plus 1 is 4. So it goes like this, and then my graph is like this, right? So that's y is equal to radical x. If I were to draw the second graph, it's a straight line. Intercept is 1, so right here. And then slope is 1/3, so 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. So it's like this, right? This is y is equal to 1/3 x plus 1. Here it doesn't say, oh, x is going from 1 to 9 or anything. It says find the area bounded by these two. So I have to kind of figure out where do they meet. So that'll be the limits of the integration. So this will be the lower limit, and this is the upper limit. I have to find exactly where they meet. I mean, no, they meet at when x is equal to 9, but algebraically, I have to check where they meet, intersect. I'm going to have to let those two functions to be equal to each other to solve algebraically. So it's like this, radical x is equal to 1/3 x. Here square both sides. So x is equal to 1/9 x squared. So that means 9x is x squared. So that's x squared minus 9x is equal to 0. So x factorial x minus 9 is 0. So x is equal to 0 and 9. So we knew that, but here I just want to verify. Sometimes graph is misleading. Maybe they meet like at 8.9. How do I know that? So here I kind of knew that, but this will tell you exactly. So that means my integral is set up like here. Top function is radical x minus that bottom function is 1/3 x plus 1. Goes from 0 to 9 dx. And as a result, you're going to get 9/2 when you calculate it out. All right, pretty much we're done. One more example 5. I'm going to have you figure that out, and then example 6 as well. And for number 5, the answer is 64/3 is the answer for number. And that's it for this worksheet.